This session on polymers is all on nucleotides and polynucleotides. It's got a strong biology link. In this session you'll be able to identify the parts of the structure of a nucleotide. It will describe how a polynucleotide is created by base pairing. This is the structure of a nucleotide. It's made up of three distinct areas. So this section here is called the ribose sugar. This section here is called the phosphate group. And this section here is the most important of all. It's called the nucleotide base. There are four bases: adenine, thymine, guanine, and cytosine. When single nucleotides join together, they make polynucleotides. So what happens is the ribose sugar connects to the phosphate group. Each nucleotide has a different base, you see here. This could be the same base, it could be different, but they're joined together in a polynucleotide chain. Now, what would normally happen is that a corresponding nucleotide chain will join up on this side. Adenine always links to thymine, guanine always links to cytosine. When I was at school, I had to remember this the same way as you have to. A to T, C to G was the easiest way to remember it. So this adenine here would link to a thymine on this side. This thymine would link to an adenine. Cytosine to guanine, guanine to cytosine. What they form is a helix chain or a double helix chain. Between the bases, or between the base pair, we have weak hydrogen bonds. Okay? We call this structure a double helix. It's held together by the sugar phosphate backbone. But this is a stretch of a polynucleotide. On the other side, we would get a corresponding polynucleotide. Now, each three of these codes for an amino acid. Okay, so we got an amino acid here, 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 and here. So we got four in total. These can code for characteristics, they can code for specific proteins, but non-coding regions allow a gene to be switched on or off.